Have you ever thought about this equation? What about this equation? Have you ever seen that in different kind of shorts or some kind of exam and you were always worried how you can solve it? So we are here to talk about that one, which is going to be algebra. My name is Mahmoud Kiasari and welcome to Special K.
Let's simplify math with Special K. Ready? Let's dive in today's topic.
So, hello all and welcome to another episode of Math is Simple. So today we are going to talk about a very interesting topic. I believe you've seen it so many times in different kind of YouTube videos. For example, if you are just you consider yourself as one top percent, you can solve this question, or in your exam, or any kind of real world problem, and you will always wonder how I can solve this one. So this is something that we call as algebra. So it means that I do have something that I call this equation. For example, x plus 3, and after that we do have an equal sign there, and we would like to consider that what point at what scenario my x, which is something that I don't know, is going to be considered as the right number for that specific equation. So let's just talk about it. The first of all is that what is algebra? As you can see over here, and without further ado, let's just talk about the wording. Algebra means that is a branch of mathematics that actually we are going to use symbols and letters in order to represent values and their relationship. Not only we are going to use it in the math itself, but also we do have the real-time scenario that we have to solve the real-time questions. Imagine that you would go to the bakery, and after that you would say that, okay, I do have 3 breads and each bread costs, for example, $2. So right now you have to solve it, that how much would be the end at the end. So right now it's just a simple multiplication. Well, what would happen if it was backward? It means that the baker would tell you that, okay, you do have $6 to pay and each of those breads costs $2. So right now, you know, each one of those breads actually costs how much. This is very simple way that we can put algebra in the real-time board. After that one, we are going to use it in science, engineering, programming, in almost everything we do have this one. So let me give you a very simple example. For instance, I do have equation x plus 3 is equals to 7. Don't worry about it. I will talk about each of those ones, why we do have x, what does it mean by equal sign. We will talk about all of them. But this is a very simple example of equation. So obviously you would just solve this one. X plus 3 is equals to 7. So what is the number that I have to find that if I add it up with 3 would be 7? It would be 4, right? Right now it's simple. So I don't have to be genius or smart about that. Only thing that I have to do, just find the number. If I add it up with 7, if I add it up with 3, it would be 7. But wait, it's going to be more and more challenging. So after that one, we do have some kind of different letters. If you just saw in the previous equation, we had x. So at the first point, we don't know what x is, but after that, either we guessed that one or we found a way in order to solve that. That specific term or that the specific letter which is unknown and its value could change during the time is going to be considered as something, we call it as a variable. So variable are letters that are going to represent the unknown numbers or some kind of or quantities. After that, we do have different kind of names for variables. If you just look at your assignment, your textbook, you can see that there are different kind of names. X, Y, Z, A, B, C, anything from the letters can be considered as a variable. Again, variable is a number that is unknown right now and it can contain anything. After that, variable can change value depending on the condition that they are. For instance, let's look at this question. I do have x plus 2 is equals to 7. So what is the number that if I add it up with 7 is added up with 2, it would be 7. That number is 5, right? What we remember from the previous question, x was another thing. And we are going to see that from the next question, it could be another thing. So it doesn't matter what number is inside the x is going to represent an unknown for you. So after that, we do have two important definitions, constants and coefficient. Imagine that I do have a question, 3x plus 4. What does that mean? So as you can see over here, the first thing that we just learned was about the x. X is a variable. I don't know about that. Right now I cannot solve it. Why? Because it's not equal to anything. So I'm not sure what is x. X could be anything. So when I don't know about x, I just consider it as a variable. Another number that is going to be beside x is something that we call a coefficient. So coefficient is a number. It could be anything. It could be a fraction, it could be a negative number, it could be a square root, it could be anything. But I know for sure that number is something constant. It's not going to be changed at all. The number that is going to be beside your variable and it's going to be multiplied by that is something we call as coefficient. Another number that is going to be beside the whole package of 3x or whatever x that is, and if you add it up or if you subtract it, remember, add or subtract. We are not talking about multiplication or division, add or subtract. That specific number, again, is not going to change at all. It's something that we call as a constant. So we just learned three things. The first one was a variable, is a letter that we don't know about. The second one is the coefficient, is a number. Again, it's the constant number. It's going to be multiplied, or at some points it can be divided by your x or variable. And after that, we do have another number beside the whole package of your 3x or whatever x is that, and it's either going to be add or subtract. That is something we call as a constant. So you tell me at this point, 5y plus 7. You see, everything has changed. But again, I do have equation. Right now, I have to say it's not equation, because equation is something that if you equal it to something. So right now, it's just some terms side by side each other. So I do have y, which is going to be my variable. I don't know about that yet. It's going to be 5 coefficient, and I do have 7 as a constant. Again, negative 2z plus 9. Z is a variable, and negative 2, again, any number could be beside your variable. Negative 2 is considered as a coefficient, 9 is the constant, x plus 3. At this point, you can see there's no number beside x. So this is something that we have to talk about. Are you agree with me that if I multiply 1 by each number, it's going to be the number itself? For instance, if I do have 1 multiplied by 3, I still do have 3, right? This fact is also going to be true about the 1 and a variable. It means that if I do have 1 multiplied, for example, by y, is still going to be y. So whenever you don't see any number beside your variable, for sure you know that number is just 1. It's not 0, it's not nothing, it's 1. So at this point, if I do have x plus 3, and if I ask you to give me the terms or the sum of the variable x, coefficient, you don't have any number, 0? No. So the number right now is just 1. And if you have the constant, the number is 3. As simple as that, right? So another thing that we do have is about algebraic expressions. The whole thing that right now we do have is going to be considered as the algebraic expressions. I do have the coefficients, I do have the variable, and after that I do have the constant. So whenever we do have any real world problem, whenever we do have some kind of an equation on the side that consider a constant number plus coefficient and a variable term, we just consider it as algebraic expression. For example, at this point, we do have 2x plus 3, 5y subtracted by 7, 4a plus b. So 4a plus b is some kind of interesting. We are not going to touch it right now, but in the future, we are going to talk about some kind of equations or algebraic expressions rather than only one variable or one unknown term. They have two. Again, it's going to be advanced math. Again, right now we are at Math 101, so we are not going to talk about it right now. But again, these guys are going to be considered as algebraic expressions. So let's talk about another term, like and unlike term. Imagine that you have apple, and after that I would ask you that right now you have another apple. So how many apples you have? Obviously you have 2, right? But imagine that I would ask you that I do have an apple and I do have an orange, and I would ask you a question, okay, how many apples you have? You still have 1, right? Because you cannot add these 2. Again, we do have the same scenario over here, like terms and unlike terms. When I do have the like terms, I can just add them up. What does that mean, the like terms? Whenever you have a variable that its exponent is as the same as another variable, in the meantime, the letter that you use for the variable is the same as another one, you would consider those two as the same or like terms. So, for example, I do have 3x and 7x. As you can see over here, and based on my definition, I didn't talk about the coefficient. As long as you have those two variables or those two letters the same, with the same exponent, again, when you don't have any exponent, it means that it's just 1. When you don't have any coefficient, it means it's just 1. So whenever you have those two like each other without considering the fact that those terms, those some kind of coefficients are not like each other, you can add them up, subtract them, or you can do anything with them. So at this point, I do have 3 apples and I do have 7 apples. I can add them up. So in total, I do have 10x. But another point is to look at the second question. I do have 5y to the power 2, negative 2y to the power 2. Still like terms. Why? Because yes, the exponents is not 1 anymore, but it's the same. Y to the power 2, y to the power 2. I can add them up. What about the last one? 4ab and 9ab. Still like terms. Why? We are not talking about exponents. We are talking about 2 terms that are just got multiplied by each other. ab and ab. As soon as you see like terms, you know that they can be simplified. Let's look at unlike terms. So 2x and 2y. Right now, we do have same coefficients, but if you remember, I didn't care about the coefficients. As long as my terms are like each other, or they do, and, this is not or, and they do have the same exponent, I can add them up or do anything with them, or I can simplify them. Let's look at this one. I do have x and I do have y. Unlike terms, but they do have the same exponents. Can I add those? Of course not. Why? Because the terms are not alike. They do have the same coefficients, which we don't care. They do have the same exponents. That's good. But remember, I do have and. It means that if I were to consider this fact that I can add or subtract or simplify these two, one is that both of those terms should be alike, and both of them should have the same exponents. One fact or one criteria is not satisfied, everything is done. You cannot do anything. So let's look at another one. 3x and 3x to the power 2. Coefficients are good, terms are good, but again, by terms I mean variables are good, but again, they don't have the same exponents. 3x to the power 1, 3x to the power 2. Again, I cannot do anything about it. 5ab and 5a. I guess this is so obvious. I do have a in both ones, but I don't have b in another one. So it means that I cannot do anything with them. So right now we just learned about some kind of like terms and unlike terms. So let's look at examples. For instance, you do have the algebraic expression 2x plus 3x plus 5y plus 7. And after that, I would ask you to simplify. Maybe some of you would say that why we're going to do that, because you see in some kind of in the future questions and something that we call as equations, you have to find a way to simplify everything as much as possible. By this way, it's going to help you to find your final answer faster and easier. So at this point, I do have 2x, 3x, 5y, and I do have 7. Obviously, I cannot do anything with 7 because, again, if you want to add some kind of a number with another thing should be a number. Rather than that, you cannot do anything, just leave it there. So I do have 2x and 3x, so I can add them up. 5x, that's good. 5x plus 5y plus 7. I cannot do anything about it. In future, when we are talking about some kind of other kind of concept, you can see that you can do something with them, but right now we just consider it as a no. 5x plus 5y plus 7 is my algebraic expression. So right now we just talk about one way. So again, this simple example is to show you that how you can add them up. 4y plus 2y, 6y, easy. 3a plus 5b plus 2a. So right now I do have different variables. That's okay. I don't have to worry about that because I know how to do it, right? 3a and 2a. Again, I do have 5a plus 5b. Stop it. You cannot do anything with that right now. 7x subtracted by 3 is plus 4. Again, 7x subtracted by 3 is 4x plus 4. So these are just some examples that how you can consider simplification or simplifying an algebraic expression. So let's just talk about another thing that actually we just had a video about it, the PEMDAS or order of operation. Again, just for a quick review, what is PEMDAS or order of operation means that whenever you have different kind of operations in your algebraic expression, you have to follow a path or follow a rule. Rather than that, you're going to face a problem. For instance, at this point, when we are talking about 2 multiplied by x plus 3 plus 5, based on the PEMDAS, we know that parentheses comes first and anything inside. So I do have this guy. I have to consider the fact that I have to do something with it. And after that, I can add it up with 5. So at this point, the question would say that, okay, imagine that x is equals 3. It means that my equation or some kind of my algebraic expression, again, I'm trying to not use the equation itself because right now we're not talking about it, but algebraic expression is just, instead of just being considered as unknown, just consider it as noun, because right now I know for a fact that x is equals to 3. 2 multiplied by 3 plus 3 plus 5. Right now I have to do the parentheses first. After that, I do have exponents. There's no exponents there. So again, for considering your understanding better, I do have the parentheses, which I just did it first. And after that, I do have exponents. There's no exponents, so forget about it. I do have multiplication and division first. And after that, I do have addition and subtraction. Again, remember, it doesn't matter which M or D comes first. M and D, or multiplication and division, they do have the same order, but you have to start from left to right. Whatever comes first. You have A and S, addition and subtraction. Whatever comes first, which is going to be the order, its order is going to be after multiplication and division. So right now, I do have 3 plus 3 is equals to 6. 2 multiplied by 6 is equals to be 12, plus 5 is equals to 17. Easy. Again, if you have any problem with that, you can just look at the video I just uploaded. But again, if you don't understand it, just ask me. I'm going to make another video for you, just following different kind of examples in order to make sure that you completely get that one. Because the PEMDAS, order of operation, is a very, very, very important part of algebraic expressions and in the future about equations. So let's talk about it. Let's talk about equation. Why I was avoiding to talk about it, because equation means that on one side you have algebraic expression considering the coefficients, considering there's some kind of unknown term or a constant, and another side you do have another algebraic expression. So by having this one equals to another one, actually we are going to find that unknown variable. Because before that, for example, I would give you x plus 3. And after that, I would ask you to find the x. So this is completely nonsense because you cannot do it. X plus 3 could be anything. This could be equals to 10, to 12, to another algebraic expression. So you don't have any idea. So that question is completely wrong from the base itself. But if I tell you that x plus 3 is equals to 7, just like the question we had, right now I say that, that's one of those aha moments. I can do it. I know for a fact that 4 is there. So right now the question is easy. But what would happen if this condition is going to be a little bit complicated? We will talk about it. So right now, again, baby steps. Baby step number one step equation. Means that the only thing that you have to do right now is just find the x itself. So based on some kind of your knowledge, if I give you this question, x plus 5 is equals to 9. So obviously you would say that, yeah, it's easy because the only number that I have is 4, right? But I'm going to show you a way that actually can solve anything. From now on, remember, when we are talking about algebraic expression, we are talking about some kind of only one variable right now with the exponent of 1. Anything rather than this is going to be considered as advanced mathematics. So right now, the only thing we are going to cover is one variable with the exponent of 1. What are we going to do? In all of the equations, if you're trying to solve something, the very best way is that to do the isolation. So what is the isolation? It's something that I would tell my students all the time, is that you consider your variable in one side of algebraic expression, and after that move other numbers to another side of algebraic expression. Move some kind of consider x as one side and move all of the numbers into another side. Maybe you would say, okay, how I can do that? Let's look at this question. X plus 5 is equals to 9. Let me give you an example. Imagine that I do have a fact that x plus 1 is equals to 0. Okay, just consider this one. Obviously, x is going to be negative 1. I'm not talking about it. Do I know that negative 1 is equals to negative 1? For some of you would say that, okay, what is that supposed to mean right now? Because it's obvious. Yeah, I know. Just consider that. Based on the very basic mathematics rules, if I do have this condition, one algebra or equation on the top and another equation on the bottom, by the way, equation on the bottom is just a fact. It's not an equation, but still can be considered as equation. I can add the left sides and I can add the right sides at the same time. Okay, so it means that at this point, what happened? I just did it. Imagine that I do have a point that there is one specific number based on my mind, based on the question itself, that I can add or subtract or multiply or divide by both sides. Again, when you're trying to do this, if I can say it's a trick, if you're trying to do this trick, you have to make sure you're going to do it for both of those parts. It means that it's not like this, that I will write in that x plus 1 subtracted by 3 is equal to 0 subtracted by 1. No, it's not working like that. Whatever number that you consider and use its operation for each side should be the same. So I do have this one, and after that I do have this one. So what is happening right now? Obviously 1 subtracted by 1 is 0, right? So I cannot do anything with that, with x plus 1 subtracted by 1. X should be isolated by itself, 1 subtracted by 1 is 0. So I do have x is equals to negative 1. Simple. What happened? Instead of just keeping number on x side, I just moved that one number to another side. There is a very, very simple way to do that, by the way, is that you consider the fact that whenever you are moving a number from one side to another side, its sign is going to be changed. If it was positive, it's going to be negative. If it was negative, it's going to be positive. That's more advanced way, but the way that I just talked about it is a fact, is a simple way. Whoever asks you why you did that, you can just show it in this example, and that guy is going to be completely convinced. So imagine that we do have this question. X plus 5 is equals to 9, right? So I told you that I can get rid of 5. How? By considering the simple fact. Negative 5 is equals to negative 5. Is that okay? So let's do it. So I do have x plus 5 subtracted by 5, which is going to be x itself. 9 subtracted by 5 is equals to 4. Just like the answer we had. That's it. Instead of just doing it in your head, you can just follow the facts. So let's see another kind of example, because we are here to work on examples, simplify everything, and after that make sure we completely understand, right? So I do have x plus 7 is equals to 10. Whenever you look at your mind and say that, okay, that is simple, I can some kind of consider 3, right? That is completely right. But again, let's work on the way that we learned. X plus 7 is equals to 10. Negative 7 is equals to negative 7. Why I'm using negative 7? Because using that, I can make x isolated. So I do have x plus 7 subtracted by 7 is equals 10 subtracted by 7. This one is just gone, 0. I do have it at 3. So x is equals to 3. Let's go for another question. Y subtracted by 4 is 6. How I can get rid of negative 4? That's right. I have to add both of those sides by positive 4. So I know positive 4 is positive 4 itself. That's a fact. So if I just add these two parts and these two parts, I will have y is equals to 10. Simple. Let's look at another question. 5z is equals to 20. This is another condition that you have to make sure that you can isolate the 5z. How I can do that? What is the coefficient, or what is the number besides z? And how I can get rid of 5? That is right, by division. Because 5z divided by 5 is actually equals to z. But wait, if I divide that 5z by 5, what should I do with 20? If you remember from the common denominator and least common denominator, whenever we are trying to multiply one number by another one, we also have to make sure another number is going to be multiplied by the number is going to move us to a right one, right? To the same number as we come to consider as a common denominator. So we also do have somehow the same way over here. It means that whenever you divide one part or one part of algebraic expression by one specific number, you also have to do the same thing with another one. So 5z divided by 5 is going to be z, that's okay, but I also have to follow this rule. 20 divided by 5 is equals to 4. So I have to do the division for this one as well. So I do have my z is equals to 4. And after that, I do have right now fractions. W over 3 is equals to 2. How I can get rid of W over 3? Are you agree with me that W over 3, if I just multiply by 3 over 1, or just 3 itself, I can get rid of it? Maybe someone would say that. How? If you remember from the multiplication that we had also another video about it, yeah, whenever you have this kind of scenarios, you have two fractions side by side and you're trying to multiply them, the only thing that you have to do, multiply the numerators and multiply the denominators. So you have 3w divided by 3. I do have 3 in both sides, on the top and on the bottom. I can cancel them out. This is something that I can do. So I do have w. It means that if I want to get rid of this 1 over 3 or this fraction, the only thing that I have to do, multiply both sides by 3. Simple as that. W is equals to 6. So Let's talk about it. Two-step equation. So there's sometimes that rather than just doing one simple addition, subtraction, multiplication, or division, we have to combine those two. What does that mean? Imagine that I do have a scenario that 2x plus 3 is equals to 11. So right now you would say that, okay, somehow I can get rid of 3, but still 2x is not going to show me that x is isolated. What can I do? I would say that it's easy. Just do the way that you did. Again, what does that mean? Look at this. So I do have 2x plus 3 is equals to 11, and right now I'm asking you to find the x itself. So the very first thing that you know is that, okay, I have to find a way to make x isolated. I do have addition and I do have multiplication at the same time. What should I do? Try to do the simple way. What is the simple way? Addition or subtraction? All the time they're the easiest one. So what can I do? I can subtract both sides from -3. Again, I'm not going to talk about it because we know it from the previous part, but subtracted by subtracted by 3, or add both of them by -3. Same, tomato. So right now I do have this part, and subtracted by 3 is going to give me something. 2x is equals to 8, and you would say that, wait a minute, x is not isolated itself because the question specifically asked to find the x. It didn't ask to find 2x. You have to be very careful. I've seen so many times people just reach to this part and say that, okay, that's fine, I'm done. No, the question asked for x, not 2x. So right now, what should I do? 2x is equals to 8, right? The only thing that you have to do is to get rid of x is just divide that one by 2. Why by 2? Because again, 2 is the only number between 2x and x. And after that, you can find the answer. Divide both of them by 2. Divide one side by 2, another one by 2, and after that you have x equals to 4. Simple as that. So what happened over here? At this point, we just call it as the two-step equations. Instead of just doing one step, division, multiplication, any other thing that you have in your mind, I do have two-step parts and I have to follow it. So another important part is that so many times I will tell my students is that check your answers. What does that mean? Imagine that you do have a question that x plus 3 is equals to 7, and based on your mental way, in your mind, or some kind of the way that we just talk about it, you found that x is equals to 4. That's okay, but try to double check your answer. What does that mean? Instead of x, put 4 and see that this equation is right or not. There are so many times that this way is going to save you. Why? At some point, you're going to, for example, forget the division, forget the addition or subtraction, or do the division or division or multiplication wrong. So by this way, you can make sure that your answer is right or not. Remember, whenever we are trying to solve an equation, we are trying to find a specific number for that equation. And if we put that number we just found from the equation itself, and if you put it there, still the equation, the left side of expression and right side of expression should be as the same. So for instance, we do have 2x plus 3 is equals to 11, and we found that x is equals to 4. And we say, okay, that's fine. Let's double check your answer. You still have time. So how we can do that? 2x plus 3, I just consider 4. 2 times 4 plus 3 is 11. Done. So I did it right. Remember, for any of those questions that you solve, try to do it this way. It doesn't matter if you are doing it for the 10th time or a millionth time. At each of those situations, there's always chance of mistake. Okay? Try to do that. So let's just have some examples, and I guess some kind of practical example, practice questions for you. I put it over there. So the first one is just simplifying it. 3x plus 4x. What is that? I do have x subtracted by 7 is equals to 2. And after that, the last one is not very important because it's not talking about the equation. It's still considered as equation, but right now my x is not only one number. We will talk about it in the future, but it's not the concern. Try to answer the first question and second question, and after that, just put your answer in the comment below. That was a Special K, or this is a Special K. Thank you for being here with me. If you just like, share, and subscribe, that would be fantastic. Have a good day, night, whatever. See you around.